Last demo for today is kernel debugging with LiveKD, and in a way we've already done this with Windows Debugger Preview. But this is the old-fashioned way to do it, and I left it in here. This is the classic way to do it because I wasn't sure how much to trust that Windows new debugger that's in beta, but in fact it works pretty well. But anyway, even if you're using the Windows 10 with tools, you still have to install the debugging tools, because the LiveKD that we're using here only knows how to launch the old original WinDbg. The new WinDbg Preview does not connect with it properly. So you have to install the old one with these steps here. You download a Microsoft Windows software development kit, and then you choose the debugging tools for Windows and install them. So when you get that done, you can go here and let's see, we're done with Minesweeper. And you open an administrator command prompt, which you can do a variety of ways. I'll just do it this way. All right. And then you do LiveKD -W. Or if you installed the 64-bit version, it's LiveKD 64 -W. It doesn't seem to matter which version you use. Okay, this then dumps the memory. It gives you the old-fashioned WinDbg here, which I think I can at least adjust the font of. If I go here, View, Font, okay. Lucida, bold, 14, okay, there. All right, so this loads it, and you can put commands down here and execute them up there. So you can do LM, for example, for loaded modules. And it gives you a list of all the currently loaded modules, and most of them do not have symbols, but a couple of them do. NT kernel, this is Windows NT OS kernel. That is the kernel itself, and it has symbols. That's what this mess is, PDB. And so there's some other module I think that also has symbols, NT dill. So NT, there's the kernel, and the kernel has kernel symbols. All right, and so now you can do a few things here, find a couple of flags, so you can examine all the modules in NT with X, NT bang star. That will list all the, oops, I got to start with X. That will list all the functions in the kernel, of which there are thousands. But it's moving pretty fast in this machine, so I don't have to figure out how to stop it. Okay, and then you can list the functions that contain the word create file, which will give you a much shorter list with star create file, star. And there's only maybe 15 of those. And then you can unassemble one of them, like this one here, NT create file. You can unassemble it with U. And these are pretty much the same thing we did with the preview. If you're debugging the live Windows, yes, well actually I'm glad you asked that question. This is really important. Now I can't normally debug a kernel on a machine I'm running. I would have to have two machines connected together. What LiveKD does is it tricks the machine into making like a dump of the kernel memory, and then it examines that. So I'm not really, I don't have full debugging features. I could not put a breakpoint in it. But I can view, so it's like a read-only version of the kernel you're examining. And I think, I remember reading his blog about this. He doesn't actually dump it and look at the dump. He tricks the, his LiveKD product tricks the WinDbg into looking at the live kernel as if it was a memory dump. But anyway, of course, you can't put a breakpoint or modify values down there. You'll crash your machine. Yeah, read only of the current Windows version I'm running. Exactly right. Yeah. Some Unix versions have tools you can analyze crash dumps. Yes, exactly right. LiveKD works fine for crash dumps. That's one common way to use it. If you have blue screens of death, what you do is you make a crash dump and you analyze it in WinDbg. Exactly. Good. So here's the assembly code for NT create file. Here's the addresses. And it's a 64-bit address, so they put an apostrophe in the middle. You can see it starts with FF. And then it has the raw hexadecimal bytes. So this subtracts 88 from RSP. And so all this junk here is the immediate value 88 as a 64-bit constant. So it subtracts 88 from RSP, which is, RSP is the stack pointer. So this is creating the stack frame, reserving 88 bytes in hexadecimal of storage available for storing whatever this routine is going to need and moving things around. And these are local variables, stack point plus 68, stack point plus 70, that sort of thing. And it's all 64-bit code because this is 64-bit Windows. And so you can see more of it if you give it a length parameter with a capital L. So if it should have repeated there. So if I do L20, then it will give me more lines of it. All right. And you can view a type information for a structure. And by the way, there should have help here, which I might have skipped over. There's .hh is the best help, I think. Yes. If you have a full memory dump, absolutely, you can do that. And that's what you do when you have a crash. You make a full memory dump, and then you can, if you pay for a service contract, you take a full memory dump, and then you email it to Microsoft, and they will go through it and figure out what the problem is. Use this to view a stack trace. Yes, you can. I think a K is a stack trace. Yep, here's the current stack trace. So this shows me right where I am. I'm here in LiveKD, and here's the all the return addresses to all these modules. That's what it is. And we think is .hh is the good stuff. Yeah, this is what you do. .hh gives you the help menu. This is the only possible way to learn how to use this thing, is to read this Windows 3.1 chum file help system. This is what teaches you what all the parameters are and everything. So for example, if I go to, let's see if I can make it look better. Okay, contents, search. If I search for, say, stack, then I will get debugging a stack overflow, which that sounds pretty good. And there you go, explaining how to do it. This tool is difficult to use, but incredibly, yes, you have to use these help documents. It's the only possible way to learn it. And this is an incredibly powerful, you can write scripts down here on this line. You can have loops and if conditions. You can make something, and I had it in one of the projects at one time, and I think I didn't make it an official project or something, where you can actually, like, I think it's in one of these, where you actually write a script that will do something like find every time it's going to use a file and then print the name of the file here. So things like that. You can write little scripts that will do complicated things. I think you can do that in Ollie too. So this thing is actually a really greatly respected skill. If you become an expert at WinDbg and the real Windows hotshots, learn how to write cool scripts that will totally find obscure problems and stuff down here. So as with everything in this course, we're only doing the barely scratching the surface of like the 3 or 4 most common commands. But this thing is really powerful and really important if you want to get into Windows. But you can do a little bit with it without knowing all the tricks. And this is where you learn what all the parameters are. The parameters are really far from obvious, like this L thing. But anyway, so you can also examine a driver. Here's a structure. You can do DT to print the definition of a data structure. So this is going to show me what underscore driver object is, which is part of the kernel. Here's what a driver object is. Type, size, flags, and here's what they are. Unicode string is driver name, and then major function, driver unload. This is the data structure of a driver object, and that's what you use, that sort of thing. Yeah, and here's the help. Good, I did have it in the project. .hh is where you really learn how to do everything. And so then there are some flags here. Now that you know how to search memory, find the Windows function that has a name like this, disassemble this module and find a command in it. So you can play around a little bit with the old-fashioned WinDbg. And the new one called WinDbg Preview is a little bit easier to use, but not in any really important way. The graphics are a little bit improved, but you really have to learn how to use these command line commands to get any real power use out of it. Anyway, that's what I wanted to show you, a little bit of kernel debugging.